Hello, Algebra. This is Mrs. Cryer, back to do day 5. I am on page 13 of the packet, exploring factors and zeros of quadratic equations. Again, apologizing in advance for my writing. I don't know how Mrs. Kelm writes so neat. Maybe she can teach me. But she hasn't yet, so you're just going to have to deal with my messy writing. The zeros of the function f of x are... So we have to take this quadratic in number 1, and we have to solve it. So I'm going to start by actually going to give myself hopefully a little bit more room. I'm going to start by setting it equal to 0. So 0 equals 3x squared minus 3x minus 6. So this is what we want to solve, and I could do this in my calculator by plugging that quadratic into y equals. I could go to the table and see where y equals 0. I could look at the graph and see where it hits the x-axis. Those are all very valid ways of solving this. I'm going to solve it by factoring, just because I think it's a good review and because it's just how I decided to solve it algebraically. I'm going to take out a 3. Now you can use a box for this factoring. If it's a more complicated GCF there, I would definitely be using a box, but we're just taking out a 3. Okay, now I'm going to take this thing in the parentheses and I'm going to X box it. So at the top I have a -2. The bottom is a -1. Two numbers that multiply to -2 and add to -1 are going to be -2. Your teacher may or may not use this box method, and that's okay. Everybody's going to get the same answer in the long run. So this x helps break that middle guy up. And now you might just go ahead and factor it from there, or you can put it into this box by grouping. That's a negative. And then I love when there's just an x squared in the corner, because then I know it's got to be x and x. -2 there, plus 1 there. Check that last box. A -2 and a +1 does give me -2. Okay, bringing it all together, I've got 3 parentheses x plus 1 parentheses x minus 2. Now it's factored. I have all multiplication in here. So I'm going to draw my lines. On this side, I got 3 equals 0. Well, that's just nonsense. 3 does not equal 0. There's no x there, so there's nothing to solve. Here, I'm going to skip the part where I write x plus 1 equals 0, partially because I ran out of room, but also because at this point we've done a lot of solving. I think you should be able to just take that and jump to x equals -1. Same here, x equals 2. It's going to be the opposite sign of whatever's in the parentheses. So my roots are -1 and 2. Be careful. All the choices look the same, similar. So we got to be really careful. I want my 1 to be negative and my 2 to be positive. There it is. Choice 2. Okay. The next one. A polynomial function has zeros, x equals -5, 2, and 9. I threw the x equals in there because I'm thinking ahead. What would be the factors of this polynomial function? So they're giving me zeros. When they're giving me zeros, like I said, I was getting a little ahead of myself, because as soon as I see the word zeros, I think to myself, okay, that means this is x equals the number. X equals -5. This would be like the end of the problem, typically. X equals 2. X equals 9. They want to know what the factors would be. Well, the factors are going to be what would be in the parentheses above this. We just talked about this at the end of the last problem. It's going to be the opposite sign. So this is going to be x plus 5. This is going to be x minus 2. This is going to be x minus 9. Those are the factors. Okay. Number 3, a polynomial function contains the factors. Okay. A polynomial function contains the factors x, x minus 3, and x plus 6. Which graphs below could represent the graph of this function? I think that's what it say. That's fine. Explain your answer. Okay, so if these are the factors, that means these guys are going to help us decide where it hits the x-axis. If I set that equal to 0, then I do my t-chart, I get x equals 0, x equals 3, I got to change the sign there, x equals negative 6. So I'm looking for the graph that has zeros, and keep in mind, your zeros are your x-intercepts. So I'm looking for zeros at 0, 3, and negative 6. Well, this middle guy doesn't hit at 0, so I'm going to get rid of him. The first one hits at 0. I want it to hit at positive 3, negative 6. This is not the correct choice. People could get fooled on that because they're looking at this and they're thinking, oh, negative 3, oh, positive 6. In case you don't know where I was pointing up here. That's wrong. The factors you have to turn into zeros before you can decide where it hits the x-axis. So now that I've turned them into zeros, I'm looking for it to hit at x equals 0, x equals 3, and x equals negative 6. This one is choice 3. Okay. Okay, I can erase some of this stuff. Okay. The next one. Which equation has the same solutions? Okay, you want to look ahead a little bit into the choices, because the way the choices are set up for this one, I can tell that they started completing the square. I can see that they have a binomial squared and a number on the other side. So that's going to tell me that I should start completing the square on that. When we start completing the square, I'm adding 7 to the other side. I'm going to take half the b value. 6 is my b value. That's going to give me 3. I'm going to take 3 and square it. That's going to give me 9. 9 is the magic number that I add to make a perfect square trinomial there. Now, whatever I do to one side, I have to do to the other. Okay, sorry, I thought my video stopped, but it did not. So I'm making sure to add 9 to both sides. You can go off to the side and go through the whole process of factoring this thing. That's not a bad idea if you're not sure where to go. But if you've done enough completing the square at this point, you probably realize, okay, over here, everybody can do 7 plus 9 to get 16. You probably realize by now, this is a perfect square trinomial because it's going to be binomial squared, and the binomial is always going to have the same sign there, plus, and half of the b. I look over at my choices, and choice 4 is matching mine. Okay. 5. Which of the following 3 functions has, given the following 3 functions, which one has the smallest minimum? Justify. Okay, so I'm looking at these 3. They're all quadratics. How do I know that? Well, the first one's a picture of a parabola. That means it's a quadratic. The next 2 have x squareds in them, so they're quadratics. When it wants to know the smallest minimum, that's going to be the y value of the turning point. So if I'm looking at this first picture, I'm finding the turning point right there. It is at 1, 1, 2, 3, 4, 5, negative 5. So y equals negative 5 is the minimum. So I'm going to find the turning point for all of these and then just compare them. Whichever one has the smallest number, y value, lowest y value, is going to be my answer. So for these guys, there's several things you can do. I'm again going to choose to do it algebraically here. So x equals negative b over 2a is going to find me my x value of the turning point. In this case, it's negative 4 over 2 times 1. I'm getting those numbers from right here. Here's b, a is 1, and this is going to give me negative 2. Now that is not my minimum because that's the x value. I have to take that x value and plug it in for x in order to get the y value there. This you would type into your calculator, okay? No reason to be a big shot. You literally just open up your home screen, parentheses, negative 2, close parentheses, squared. Make sure that squared's on the outside. Plus 4, parentheses, negative 2, parentheses, plus 4. Enter. Calculator tells you 0. Okay, that means my turning point is at negative 2, 0. Guess what? The minimum number is 0. That's the lowest it goes. So right now the first one's winning in terms of smallest minimum. Okay, I'm not going to go through this. I think you should pause the video, see what you get for the turning point, and then turn it back on. Pause it now. Okay, I'm going to keep going. X equals negative b over 2a in this case gives me negative 1. And when I plug negative 1 in, I got negative 25. So my minimum here is negative 1, negative 25. Y equals negative 25 is the lowest that parabola goes. This guy's our winner because negative 25 is smaller than 0 and smaller than negative 5. Okay, we're on page 14 now. Number 6 says, let me zoom in a little bit here. Polynomial function is graphed to the right. State the domain. Domain is the x values. That's how far left and how far right this thing goes. I definitely see an arrow here and an arrow here. Yes, it's pointing down, but it's also going left. Okay, and yes, it's pointing up, but it's also going right. It's going left and right forever. So my answer for the domain, I like to put a D in front just to signify domain, is negative infinity to positive infinity. Range, this thing is going down and up forever. There's no holes in it, no breaks in it. So the range is also negative infinity to positive infinity. It wants me to find f of 0. So f of 0 is going to be when the x value is 0. If this is in parentheses, that means that's my x value. So that means I'm not going left or right. I'm staying at 0 and figuring out where it hits the function, right up there. So that is at 1, 2, 3, 4. So the answer to that is 4. What's the name for this point? Well, when x is 0, it hits the y-axis. That is the y-intercept. D, for what interval or intervals is the function decreasing? Okay, I'm going to have to erase a little bit to do this one. So decreasing, I think that it's not that hard for students to highlight where it's decreasing. Like if I'm following along and I have to draw it left to right, that's the key. You have to draw it left to right. Anytime you're answering an interval, you got to think about, for domain, it's left to right. For range, it's bottom to top. If I'm increasing, this is going up, okay, if I'm drawing it. This section, I changed colors, the green is going down. And then that last section, it's going up. And I don't think that's hard for people to see. The hard part about answering increasing and decreasing is relating it to the x-axis. So if I'm looking at my decreasing part, where does that line up with the x-axis? Well, starting here, that's at negative 1. And then going to the end of where it decreases, that's at 2. Notice I'm not looking at the y-axis at all. This function is decreasing over the interval negative 1 to positive 2 because that's where the part that's going down lines up with the x-axis. E, for what interval or intervals is the function increasing? So I'm going back to where my yellow highlighter is. And people might want to be like, oh, it starts increasing right here. Well, that's an arrowhead. That's telling you that it's going in that direction forever. So where does it start? At negative infinity. If I'm like sort of highlighting my x-axis for where it's increasing, I'm starting at negative infinity. Where does it stop increasing and start decreasing? Well, that same number that we talked about before, -1. But that's not the only place it increases. It decreases where my green highlighter is, but then it starts increasing again at 2 and continues to increase the rest of the way. This is from 2 to infinity. It's increasing. Now, some of you may have seen notation where you put this fancy union in the middle. If you didn't, that's okay. All right, I'm on F. What are the zeros of this function? Let me erase a little bit. Did a lot of stuff there. I don't know why it's not erasing my highlighter, but that's okay. What are the zeros of the function? Well, the zeros are going to be where it hits the x-axis. So I'm looking at those three values right there. I'm looking at x equals -2. I'm looking at x equals 1. And I'm looking at x equals 3. Those are the zeros of the function. What are the factors? So again, zeros, x equals a number. Factors, x plus 2, x minus 1, x minus 3. What happened from there to there? I changed the sign. From there to there, I changed the sign. There to there, I changed the sign. These are the factors. Okay, I got to speed it up here. So I'm just going to talk about these last few. H is actually a lengthy problem. It says, which equations represent the graph? Explain above. So if you look at these three choices, they have it partially factored, okay? So number 1, they have it partially factored. They've got an x plus 2. Now, your job would be to actually take that and factor it. Okay, I already did that work on my paper. I'm going to skip going through that because you already saw me do some factoring on the last page. When I take that and go through the whole thing of factoring, I get x plus 2, x minus 6. I already know that choice 1 does not match the graph up here. How do I know that? Because in factored form, this would have to match that, and it does not. So choice 1 out of the running. Choice 2, you can see they have an x minus 3 there. I took this x squared plus x minus 2 and I factored it. Again, you can pause the video, factor it, and then unpause it to see if you get the same thing as me. When I factored it, I got x plus 2, x minus 1. Hey, that matches that. Doesn't matter what order they're in. I got an x minus 3, I got an x minus 3, I got an x plus 2, I got an x plus 2, I got an x minus 1, I got an x minus 1. Great. They're the same. They're the exact same function. If I were to graph number 2, it would look exactly like this picture up here. So number 2 is good. It's a match. Number 3, when I factored it, it was not a match. It was x minus 1, which they already had. And then when I factored the rest, I got x minus 6 and x plus 1. It was no good. Only choice 2. At the bottom, this is very similar to the last one on the page before, except this time they're asking me which function below would have the largest maximum. So instead of smallest minimum, now I'm looking for the biggest y value. So again, I'm going to find the turning point. The turning point, when they give me a picture, is super easy. 1, 1, 2, 3, 4, 5, 6. So if the turning point is 1, 6, the maximum value is the y value at 6. The next one, what I would do is type it into the calculator. You could multiply it out. You're going to make a lot of work for yourself if you start doing that. If I just put that in y equals exactly as is, go to y equals, parentheses 5 minus x, parentheses 3 plus x, and go to the table, you will find a turning point in there. At this point, you should be familiar with what a turning point looks like in a table. And 7, 12, 15, 16, 15. You guys are going to be writing much neater than me. 12, 7. You can see my turning point right in here. You see those two match, those two match, those two match. That means my turning point is 116. So my maximum value is 16. I'm going to stop there. This guy, I did x equals negative b over 2a, and I plugged that value in to get a turning point of negative 211. So my y value is 11. And this guy, you can see that the turning point would have to be in between here. That is not going to be higher than 16. So 16 is the winner for the highest maximum, largest maximum. All right, so that is day 5. Sorry, I ran long again. I swear I'm going to try and get better at that the next time I do one of these. All right, bye everybody.